So in this lesson, we'll look at descriptive statistics, where it only applies to the sample studied, and we'll be looking at mean, median, and mode. These are measures of central tendency. However, it is important that your data fits the normal or Gaussian distribution. This is a theoretical distribution where statisticians have developed probabilities based on this normal distribution. Therefore, if your distribution is not normal, then you cannot use the probabilities from this normal distribution, as most of the statistical tests are based on this probability. You will have to either transform your data or use non-parametric statistics. So this is how a normal distribution looks like. So a shape of normal distribution where the mean, median, and mode should be equal. We'll come to the definition of these measures later on. The shape of the distribution is mesokurtic with a kurtosis of 3. Here is the average, and you can see that this is 1 standard deviation away from the mean, 2 standard deviation, and 3 standard deviations away from the mean. So this is actually quite useful because we usually use this to describe the variability of your data. So if you state an average plus minus of 1 standard deviation, so that covers 68.3% of your data distribution. Whereas if you use an average plus minus of 2 times standard deviation, you'll be covering 95.5% of your data. And if you use 3 times plus minus 3 times standard deviation, you are covering 99.7% of your data distribution. So other than normal distribution, you have non-normal distribution, where you have negatively skewed data, where this is negatively skewed, where the mean is less than the median, and also positively skewed data, where the mean is more than median. You also have exponential, Weibull, and Poisson distribution. These are all non-normal distribution. So for microbiology, when we are doing direct counts, we are interested in the Poisson distribution. So kurtosis shows the shape of the distribution. So the blue line here shows the mesokurtic normal distribution. So kurtosis is 3, whereas excess kurtosis is 0. So excess kurtosis is calculated by using the calculated kurtosis minus 3. So leptokurtic line, the green line here, has a kurtosis of more than 3. It is sharp and has more extreme events. If you look at this N here, so it has more extreme events relative to the normal distribution. Whereas for platykurtic, the flatter curve, the red line here, it is flat, kurtosis of less than 3, and has less extreme events on both ends. So once you have collected your data, you have to see whether your data fit normal distribution. So you can use the commonly used test, for example the Shapiro-Wilks test, Anderson-Darling test, which can compare your data with a theoretical normal distribution. So this is usually suitable when your n is more than 100. However, you have to be careful, because if you have very large sample sizes, slight deviation from normal will also give a significant probability, significant p-value. If your sample size is extremely large, it might be better for you to use a Jacques-Barra test, which is based on the skewness and kurtosis. You can look at how I've done some of these tests in past in the following YouTube. So let's see how we measure central tendency if your data fits normal distribution. So we'll be looking at average or mean, where the sum of the data is divided by the number of data. We'll be looking at mode, where the value that appears most often in your data. Median, the value that separates the upper half from the lower half of your data. However, in microbiology, colony forming unit counts, CFU counts, have wide and fluctuating range and does not fit normal distribution. Therefore, it is better if we use geometric mean, where we calculate the average of log transform count data and then we anti-log it. So now let's see how we can do this. So this is the chromocult agar counts. So this is non-normal data, and to normalize it, I will log transform it. Okay. So after transformation, we can calculate the mean in Excel by using the term average and then selecting the range here. Okay, for median it's the same. And for mode, you use this. Okay, so mode is not available because none of the all the numbers occur only once. So if you look at this, I've replicated one data here. Okay, so it should work. Okay, so that gives you a mode. If you're looking at descriptive data statistics, you can easily come here and choose the range here and do an output range, summary statistics, and here. Okay, so this will give you all the summary statistics that you require, including your mode. So since this is CFU counts and you are interested in the geometric mean of this data, I've already mentioned you can get the geometric mean by averaging the log data. Okay, and then to get the geometric mean, you have to anti-log it, which is just this. This is log 10, so base 10 of this. So this is the geometric mean for the distribution here. So this is how you can use Excel to calculate the mean, median, mode, and also geometric mean of your data. Thank you very much.